Okay, so we were going to move ahead to the AMC problem, but I need you guys to really think and sort of discover this property, because it's a really critical property of perpendicular bisectors. It has nothing to do with triangles. There's something special about that line. It's the perpendicular bisector.
Something special.
So we've already said that it bisects the line, but what else does this perpendicular bisector do?
Yeah, what else?
So perpendicular bisector cuts the line at a 90-degree angle and then cuts it in half. So what else does it do? So the line goes on forever.
Yeah, the line goes on forever.
So maybe some points on the line.
Okay, what is special about some of those points on the line?
So you can always create like a tangent, like maybe an ellipse or an oval with that.
Well, I see something special about these points.
Okay.
So they're on this line. Any point on this line, like I'm just gonna draw in a random point.
Okay.
This point, and then you draw these lines. These are the same distance.
Okay.
It's the same. They're the same distance away from the vertices of our line segment.
Interesting. Why is that the case?
Well, because the perpendicular bisector cuts the side in half. So that these are the same length.
Okay.
So then if you sort of move up, it's just sort of stretching this original line segment.
Okay, that's an interesting way to think about it. Do you see that? Why don't you draw in another point on that line and draw in those line segments?
This point, then here and here, and then these would be the same length.
Okay. Do you see why?
Because so if it cuts the line in half, then these are both going to be the same distance away from this point.
Okay.
Yeah.
Now, what's another argument actually involving triangles that would tell us that these two line segments are the same length?
So these
It's sort of congruency.
Okay.
Because if you look at this triangle that you made,
Which one? There's two triangles
this first triangle.
there. Actually, tell you what, let's avoid the complexity and draw one on here. Okay.
So we know that these angles, this is 90.
Okay.
We know that these sides are the same
Why?
because it's a perpendicular bisector,
Okay.
and we know that they share that side.
Okay.
So it's side angle side congruency. Since these two sides are the same
Uh-huh.
and they share this angle, it means that this third side is the same.
Okay. And we don't even have to know, because this is a right triangle, we don't even have to know the side angle side congruency ideas, because we could just use the Pythagorean theorem.
Yeah.
This side squared plus this side squared has to equal this side squared. So whatever distance is there and distance is there, the squares add up to the square of that distance.
and they share this line.
Right, and so that distance has to be the same because it's exactly the same idea. Okay, so the important thing about perpendicular bisectors is what?
So a random point, any point on the perpendicular bisector is the same distance away from both of the points on the line segment, endpoints on the line segment.
Very good. Okay, good. All right, let's move on to the actual AMC problem.
Okay.